Hey, today we are going to look at Carnot mapping, or what we call K-mapping, for simplifying logic expressions. The first few slides are going to be confusing. Throwing a lot of information at you, but just try to follow, just try to keep up, and I'll slowly build up the understanding. So we're going to look at 2, 3, and 4 variable K-maps. We're going to use K-mapping to simplify logic designs. We're also going to learn about something called don't care conditions. And basically what we're going to do is we are going to take the method of Boolean algebra simplification and just do it a different way. The three line equal sign means logical equivalence. So we're going to come up with a way right here where we just put everything into a little table or map, and we can pull the simplified expression right out of the map. And so these are going to be logically equivalent. So K-maps are a graphical technique that we use to simplify logic equations. You do have to kind of get used to a new procedure, but it's a lot cleaner and neater and simpler and faster once you learn how to do it than Boolean simplification was. K-maps can be used for any number of input variables, but doing it by hand, it's only practical really for 2, 3, and 4 variables. So those are the only kind of problems that we're going to look at. So think about a truth table. Each min term in a truth table, or actually each row of a truth table corresponds to one cell in here. So this one is a 3 variable, so this would have 8 rows, so 8 cells, right? This cell right here, it would be not A, not B, and not C, so that would be 0, 0, 0, and then the output would be 0. This cell right here, not A, not B, and C, that would be 0, 0, 1, and then the output for that cell would be a 1. K-map cells are labeled. The labeling of a K-map cell is super important. Each from one cell to the next, the variable can only differ by 1. So from not C, that'll change to C. Over here we have not A and not B. Only one of those can change for our next row. So we say, all right, let's change the B. Now only one of these can change, but if we change the B back, we already have that row, so we need to change the A. And now only one of these can be changed. And if we change the A back, we would just be right back to there. So we need to change the B. So only one variable can change from one row to the next. And that's important because then we use side-by-side rows to start simplifying. And then at the end, the sum of products expression is you get by putting an OR with all the little min terms that you get from our little groups that we're going to do. So we group the ones, and then we add together with ORs those min terms that we get from our groups. Okay, so that's kind of like the preview of what we're going to do. Now let's talk about this little example right here. This is a 2 variable one. This one right here says we have a min term that is not W and not X. And this one right here says we have a min term that is not W and not X. So if we wrote out those min terms, this one here is the not W and not X. This term here is the W and not X. And then we OR those together, right? But look what happens because these are only you have a not W and a W right next to each other. Look what happens when you factor out the X. You get not W or W. Not W or W, that's one of our first Boolean theorems. Not something or it, that's 1. There's a 100% chance that not something or something will happen. You either don't have W or you do. So that's a 1. 1 times not X is just not X. So this is like the Boolean simplification version. What we do is we say, all right, I'm going to group these ones as a pair, and then look and see what stays and what goes away. So we have not x here, we have not w and w. Those are going to undo each other, so we just have not x for this one. So we look at groups of our ones, and we can identify what the minterm is based off of that. And we're going to do a bunch of little practice problems to help build our understanding as we work through this lesson. Okay, so here, first thing we want to do is we want to look at how we transfer information from the truth table over to the K-map. So remember that, so one thing is the last variable in our truth table will go on the top of our K-map, and then the stuff on the left will go on the left. And then we'll write, so our variable is x, we'll put x, not x and x on the top. This variable is w, so not w and w on the side. Now, if you look at this box here, this box is not w and not x, which if you think about it, that's 0 and a 0, right? So 0, 0, that cell corresponds to this row. Like they call it row 0. So in box 0, we would put a 1 because that's the output for when the inputs are 0 and 0, not w and not x. Then in this box, this is not w and x. So that would be 0, 1. So that's right here, 0, 1, a 0 for w and a 1 for x, results in a 0 for the output, and that one goes here. Then in this box, box number 2, we have w and not x. So that's a 1 and a 0. So that's right here, the w and the not x. It's this row. So the output for that box is a 1. And then if you look here, the last box, box 3, is a w and an x. That's a 1 and a 1. So that's that row. So our output is a 0, and that goes there. So for a 2-variable K-map, that's how we would do the that's how we would fill in the box. And if you notice it, as long as you label it like this, not XX, not WW, then it goes like this, row 1, row 2. It goes like this, row 1, row 2, row 3, row 4. Or if the row 0, row 1, row 2, row 3. So that is for a 2-variable K-map. Now let's look at the different groupings that we can do. So it is possible you can have a group of 1, right? Let's say you only have a single 1 in your K-map, then that's how you would read that. This is not A and not B. If you have a 1 here, then our minterm is A and not B. If you have a 1 here, then your term would be not A and B because you got not A and B. If you have a 1 here, then the term would be A and B. So that's groups of 1 if you only have a 1. But if you have groups of 2, so you have a couple of 1s here, if they're side by side, then up here, the not B and B are going to cancel each other out, and you're just going to be left with not A. So if you have 2 1s next to each other, look to see what cancels out. The row they line up with, that's going to be the minterm for that. If you have a pair of 1s down here, again, the not B and B are going to cancel each other out, and you're going to be left over with just A. If they're lined up vertically, in this case, the not A and A cancel each other out, and we're left with just not B. And if the 1s are lined up here, again, the not A and A will cancel each other, but since these ones are lined up under B, then that simplifies to just B. Then you can also have a group of 4, right? In which case, this would simplify to just being the function equals 1, because it'll always be true. So we can look for singles, we can look for pairs, we can look for quads. This is a bunch of instructions that includes, if we're going further, like any hex pair, any groups of 6 or groups of 8. Those will happen sometimes, but they're not very common. So we're looking at pairs, singles, and quads mostly. And then, so you're looking for the ones to be grouped. And it's kind of easier if we just try to understand that bit as we work through some examples. Okay, so I'm going to take my k, since it's my last variable, and put it on the top. And then I put a not over the first one. And then my j, since that's my first variable on the left there, I'm going to put my j's on the left. And I'm going to put a not over the first one. So then this circle here, or this square, is not j and not k. So that's a 0, 0, which is this row right here. So that spot would get a 1. This square here is a not j and a k. So that's a 0, 1, which is this row. A 0 for j and a 1 for k. The output is a 1. For this circle here, that's a j and a not k, so that's a 1, 0. So that is this row here, and our output is a 0 for that square. This last square is j and k, so that's a 1 and a 1, bottom row, and our output is 0. So now we look at our k map and we circle pairs. First, we would look to see if we had a 4 in a row, or a block of 4, which we don't. Then we look for pairs. Here we have a pair. And then what's going to cancel out? The not k and k, and we'll be left with not j. So this function is just not j. So there is like the version where I work it out and show you. Then they just kind of show you the answer on the next slide. Make sure we did it right. Yep, we win. All right, now let's take a look at this one. How do we transfer information from a 3-variable truth table to a 3-variable k map? So what we're going to do is we start with the y on top, not y and then y, and then we'll use these 2 variables for the front. So wx, 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 wx. Then we have to be careful about our nots. We always start with both of them negated. Then we take off the second one, take off the first one, and then put it back on the second one. This is the order we go in. So you got to remember that. Okay, now let's look at the way that this gets fed into our table here. In this first square, which corresponds to row 0 over here, we have 0, 0, 0, right? Not w, not x, not y. So that's a 0, 0, 0. So that's this row. Our output is a 1, so we put a 1 in that box. This box here is a 0, 0, 1. So that is minterm 1 here, and our output is a 0. For this box, we're doing a 0, 1, 0. That is this row, and our output is a 0. Here we have 0, 1, 1. And that is this row, so our output is a 0. Now, this is the part where it doesn't really follow the same pattern in our boxes. So look at the letters. We have W and X and not Y. So this would be 1, 1, 0. You can see that 1, 1, 0, that's row 6, or minterm 6 here. So our output is a 1. In this box here, we have W and X and Y, so that would be a 1, 1, 1, which is minterm 7. That's a 0. Then in this box down here, we have a 1, 0, 0, and that is this row with minterm 4. Output is a 0. And then the last one here is a 1, 0, 1. So 1, 0, and 1. And the output is a 1. So that is how they go into the boxes there. So let me erase this real quick so you can see that. So that run goes there, that one goes there. That's the pattern it follows, right? All right, so now let's look at the way we can do groupings. So they're not showing us the groups of 1, but you could have a 1 in any one of these spots in that and just circle it by itself. There's 12 different ways that you can do groups of 2 here. There's 1. So if they group side by side, you got the not C and C cancel out. So you just have the not A and not B. It could be here next to each other. So that would be not A and B. If they're there, that's just A and B. If they're there, that's A and not B. Then we can have, they could be lined up vertically. So if they're lined up vertically like this, you got to still look at, so we're going to have a not C. The not B and the B cancel each other out, but we have not A in both. So together, this, if these two are paired, then that simplifies as not A and not C. Only the B and not B cancel each other out. Similarly here, so that was 5, 6. There's, and then 7, 8, 9, 10. It says that there's 12 ways to do pairs. So what are the other 2? They are top to bottom. You could consider that a pair, where here the A and not A cancel each other. So you're going to have not B and not C. Or that pair right there. So you compare from top to bottom, and we'll see when we have a bigger one, you compare from the right side to the left side also. But when it's only 2 wide, that doesn't make any sense. Saying that you're going to pair these 2 compared to pairing this one with that one, that's the same thing. Okay, so those are the ways that we can make groupings. Or you can have groups of 4. There's 6 ways you can have groups of 4. You can have one there. In this case, all this stuff cancels each other out, and all we're left with is not C. Similarly, we could have 4 in a row here, and that would simplify to just C. Or we could have a block. In the block, the C and not C cancel each other out, and the B and not B cancel each other out, so that just leaves A. So if you get a block, you simplify even more, right? The bigger groups you make, the more it simplifies. And then there are the top and bottom here. And if you have a group of 8, everybody's a 1, then the whole logic expression reduces to just 1, because it's always going to be a 1. Okay, so now let's look at a 3-variable K-map. Here we have a 3-variable truth table. So I am going to start by putting my G on top. Do not G and G. Then on the sides, we're going to do EF. So EF, 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 EF. And then the pattern where we put the negations is important, right? We're going to do 2 nots on the first one. And then you can remember, we can only change one variable each time. So if we change the F first, so that will leave the E as a knot. Then we change the E so that they're both yes. Then we put the negation over the F on the last one. So it goes 2 negatives, then just 1 negative, then they're both positive, then the last one's negative. So now let's fill out the information, right? So this box here is a 0, 0, 0. So that is that one. So that's a 0. This box is 0, 0, 1. 0, 0, 1 is right here, so that'll get a 1. This box here is a 0, 1, 0. So that is that row. So that will get a 1. This box is 0, 1, 1. 0, 1, 1's right there. The output is 0. This one right here, E and F and not G, that's a 1, 1, 0, which is right here. 1, 1, 0. The output for that square is a 1. This box is E, F, and G, so that's 1, 1, 1, which is that bottom row, and the output is a 0. E, not F, not G, that's 1, 0, 0, which is right here. So that one has an output of 0. And then the last box would be a 1, 0, 1, which is right there, and that is a 1. So now I'm going to look for grouping. I have a pair right here. And I have a pair top to bottom right here. So in order to write my logic expression, this one right here will have it'll have a not G because that's the column it's on. And then the not E and E cancel out, so we will have F. So this pair is F and not G. This pair here is going to be G. It's going to have a G, so I need to do OR. It'll have a G. And then we have E not F, not E, not F. The not E and the E are going to cancel, and we'll just have not F. So not F. So that would be our simplified logic expression for this one. And here is the answer: F and not G, or not F and G. So pretty much how we did it there. Okay, now, can you start to see why we're not going to do this with 5 variables? Well, that is a big old truth table. So when we have a 4 variable K-map, the last 2 variables go on the top. The first 2 variables go on the left. And then it's the same pattern, right? When we did the 2 variables on this side, it was 2 negations, then just on the first one, then they were both didn't have them, and then just on the last one. Same pattern here. Both not, then just not the first one, then both of them are regular, and then only not on the last one. So this is the way that we have to label the outside. Then the inside kind of follows this pattern, right? 0, 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14, 15. That's one thing to do. Remember that pattern. The other way is to just think about this. If it has a negation, it's a 0. If it doesn't, it's a 1. So this would be 0, 0, 0, 0. That is the first row. So that one is a 0. This one is 0, 0, 0, 1. So that is this guy right here. So that's a 1. This box is 0, 0, 1, 1. That is right here. So that one's a 0. This box is 0, 0, 1, 0. That is this row. So we get a 1. Down here, 0, 1, 0, 0. That is this row. So we're going to put a 1 there. This box is 0, 1, 0, 1. That is this row. So we should put a 1 there. Then we have 0, 1, 1, 1. That is this row. So that's a 1. Then we have 0, 1, 0, 1. Wait a minute, I thought we already did that. No, 0, 1, 1, 0. 1, 0, yeah. So 0, 1, 1, 0, that is this row here, so that's a 0. Down here, this is 1, 1, 0, 0. 1, 1, 0, 0 is right here. So this will be a 1. 0, 0, no, these are 1s. 1, 1, 0, 1. 1, 1, 0, 1 is right here. So this will be a 0. This one is 1, 1, 1, 1. That's all 1s. That's the bottom row right here. So the output is a 1. This one is 1, 1, 1, 0. That is this row. Also a 1. This one is a 1, 0, 0, 0. That is right here, row 8. So that's a 0. 1, 0, 0, 1. That is row 9. So it's a 0. Then we got 1, 0, 1, 1. That is row 11. So we got a 0 there. Last box, 1, 0, 1, 0. That is row 10. So the output is a 1. So that is the way we get our information from our truth table into our K-map. Now let's look at, this is going to look ugly for a second. Now let's look at the way we can group things. There are 16 groups of 1 possible, right? We're not going to show those. Groups of 2, they can be next to each other as pairs. Groups of 4, there are 24 different groups of 4. We'll show you 7 of them. We're not going to show you all the blocks on the inside. There's like 2 by 2 blocks. There's rows of 4. Here are the ones that might not be super obvious, right? The top to bottom blocks. 1, 2, 3 of them. The side to side blocks. 1, 2, 3 of them. And the corner block. The rest of them are just either columns or rows or square blocks. But you can have groups of 8 in here. You can have like long ways, or you can have top to bottom, side to side. There's one group of 16. Okay, so now let's look at an example. All right, so we need to label our K-map. So T and U will go on the top. So TU, 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 TU. Remember we do, that's annoying. We do 2 lines on the first one, then just on the T, then off both, then just on the U. On the side, we're doing R and S. So RS, I can do the 2 lines. RS, only over the R. RS, no lines there. RS, line over the S. Now we're going to start filling in our K-map, right? So 0, 0, 0, 0. That's a 0. 0, 0, 0, 1. That's a 1. 0, 0, 1, 1. That is this row. So that's a 1. 0, 0, 1, 0. That's the third row down. So that one is a 0. So for here, we have 0, 1, 0, 0. And that's this row. So the output's a 0. For this one, we got 0, 1, 0, 1. It's this row, so that's a 1. For the next box, we're doing 0, 1, 1, 1, which is this row. So that's a 1. And then 0, 1, 1, 0. That's this row. So the output is a 1. Down here, we've got 1, 1, 0, 0, which is right here. So that's a 1. Then we do 1, 1, 0, 1, which is right here. So this guy is a 0. Then we're doing 1, 1, 1, 1. That's the bottom row. Output is a 1. Then we're doing 1, 1, 1, 0, which is that row. So this is a 1. Down here, we've got 1, 0, 0, 0. That is this row. So the output is a 0. Next box is a 1, 0, 0, 1. That's right here. So that outputs a 1. The next box is 1, 0, 1, 1, which is right here. That's a 0. The last box is 1, 0, 1, 0, which is right here. And that is a 0. So now we are going to look for the biggest groupings that we can make. It looks to me like the biggest grouping I see here is a group of 4 ones. I have a box of 4 ones right here. I also have a box of 4 ones down here, and it's okay to overlap because you always want to make a bigger group than it's always better to make a bigger group than 2 smaller groups. So instead of doing like, oh, I'll circle this pair and then I have 1 left over, it's just better to do, why does it do that? I don't know, it just does it. And then let's see. Now, you might be tempted to say, try this one more time. You might be tempted to, hang on, let me recircle that. You might be tempted to say, oh, this one's by itself and this one's by itself. Problem with that is we can do it a simpler way. Remember, it's always better to do a bigger group if possible. So rather than circling one by itself, look to see if you can make a pair with it. And it looks like, look, we can do the side-to-side pair with this one. And with this guy right here, we can do the top-to-bottom pairing. So now we just need to write our min terms, okay? So this is F3. So from the big one, so let's start with, I'll go through them in a different color. Let's start with this one. This one, the U and the not U will cancel out, so we're going to have a T. And in this one, the not R and R cancel out, so we're going to have an S. So this one goes to TS. So this box we did in green here is just TS. So now we can do the second box here. The second box here, the T and not T will cancel out, so we will have a U. And the not S and S cancel out, so we're going to have not R. Then look at the pairs. So this pair up here has not T and U. Not T, U. And then what letter over here? We got the not R and the R will cancel out, so we just have not S. So not S. And then this pair here, it's going to have R and S. And then up here, we've got not T, not U, and T, not U. The not t and t will cancel, the not u will stay. So that is our simplified logic expression. Imagine if you had started by writing out all 1, 2, 3, 4, 5, 6, 7, 8, 9 four-term minterms, and then simplifying, right? The first one would have been not R, not S, not T, U. Or then the second one would be not R, not S, T, U. And you'd have 9 of those and then have to do a bunch of algebra. So I'd much rather do this. Boom, 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 boom. Yep, we win. Okay, now we talked about something called a don't care condition. This doesn't mean that you don't care about school. This is a different one. A don't care condition for us is marked by an X in a truth table, and we put an X instead of a 0 or 1 when the overall output doesn't care whether that's a 0 or 1. The circuit doesn't really depend on whether that's a 0 or 1, the overall output. So you'll see them sometimes, and you're not going to be like, where do I have to put an X yet? You'll see an X in a truth table. So what we're going to look at is how we treat those X's, not how we come up with them. So a don't care condition, meaning an X, can be treated as a 0 or a 1. You get to pick. If you treat it as a 0, you don't have to circle it. You only treat it as a 1 if it allows you to make a larger grouping. Because a larger grouping results in a simpler equation. So let's look at an example, or not an example yet. Some you group, some you don't. Like this one right here doesn't give us an opportunity to make a pair with a 1 anywhere. But this one does. So this one we'll treat as a 1. This one we'll treat as a 0. We don't have to write a 1 and 0 on them. We'll still leave them X. But just to show you, if one of them makes it possible to have a pair, then you use it. If one of them doesn't, then you just leave it, treat it as a 0. Okay, so again, we're going to do the TU on the top. RS on the side. And then we'll start working our way through. So 0, 0, 0, 0, that's an X. 0, 0, 0, 1, that's a 0. 0, 0, 1, 1, that's row 4, so that's an X. 0, 0, 1, 0 is right here, that's a 1. 0, 1, 0, 0 is right here, so that's a 0. 0, 1, 0, 1 is right here, that's an X. 0, 1, 1, 1 is down here, that's a 1. 0, 1, 1, 0 is right here. That's an X. It don't care. Down here, we've got 1, 1, 0, 0. That is down here. This is an X. 1, 1, 0, 1 is right here. That's a 0. 1, 1, 1, 1 is the bottom. That's a 0. 1, 1, 1, 0 is this guy. That output is a 0. 1, 0, 0, 0 is right here. That's a 1. 1, 0, 0, 1 right here. So that's a 1. 1, 0, 1, 1 is right here. So that's an X. And 1, 0, 1, 0 is right here. That is a 1. Now we're going to look for groups. I see on the bottom row, I have 4 in a row if I treat this as a 1. Up here, I get a box if I treat these two X's as 1s. Then what else can I do? Remember, you're always looking to pair. If you see X's by themselves, you'd much rather pair them than circle them by themselves. Well, let's write the min terms that we get for these. So for the square up here, the U and the not U will cancel out, so we're going to get a T, F. So we will have a T, and then the not S and S cancel out, so not R. So not R and T we get from our square group. Then from our 4 in a row line here, this is R and not S. So we put or, R and not S. Now we're going to look at the pairs, right? So I can make a pair right here, but I don't need to, right? Aren't all my ones already circled? So I don't have to circle anything else. That means that this baby is already all simplified. So since there's no more 1s, I don't have to circle any of these X's. I can treat them as 0s because they don't help me. So this is it. Not R and T or R and not S. Not R and T or R and not S. Boom. Okay, so that is your introduction to K-maps.